All right, let's see how well this works. Good morning. We're going to do assignment 7-1, so if you haven't printed out or looked at it, you need to have that out. That'll make your life a little better. But what we're going to talk about today is definite integrals. We've talked about definite integrals and indefinite integrals before. I haven't really explained them though. Okay, so definite integrals an integral where I want to start at one place and in another place. So for example, we've traditionally been doing like 0 to 3. I'm going to talk about like x squared dx, which would be the integral. Oh, this is terrible. Sorry about this. Little tiny slate. Of this parabola from starting at 0 and ending at 3. So I want to find the area from in this little area right here. Right? And so the way we'd find that, which we already know how to do, would be x to the third over 3. And then we plug in a 3 and we get 27 over 3 and we get 9. So the area underneath this area right here is 9. Now we're being really short-sighted. We haven't actually done a lot of things we should be doing here. Okay, so some thoughts. First of all, what happened to c? Okay, when we do an integral, we should get x to the third over 3 plus c. Okay, now c is our initial condition. But if I'm starting at 0, and ending at 3, does it matter how much I started with? So in other words, if I have 10 gallons of water inside of my bathtub at time equals 0, that's great. Okay, but if I want to know how much is filled between 0 and 3, how much was in the tub to begin with doesn't matter. Okay, only that matters is how much has it grown since time equals 0. And so this is very interesting because we now are looking at, there's an initial condition. Okay, the initial condition is our starting point. I want to know how much has changed from 0 to 3, not just sometime in the future. Okay, so we did indefinite integrals. What we're doing is, and that's this thing down here, we're doing indefinite integrals. What we're doing is, I want an equation that works for any time in the future. Okay, what we're doing now is, how much has it changed, or how much water is in the tub, or how much have we accrued since time equals the beginning point, okay, which is going to be the bottom of my graph, okay, to the end point. Okay, all right. So that's one thing. Okay, so the second thing is this. I can start with, oh, I may need a new thing. Hold on. New piece of paper. Give me a new piece of paper. New piece of paper. No, I don't want to save that. Okay. So what if I want to start at 1 and go to 3 x squared dx? Now the problem is the integral we've thus far discussed always goes from 0. Okay, since it always goes from 0, I have no way to start at 1. But what we're really going to do is this. We're going to go ahead and do the integral to 3, right? And that would give us this kind of lightly shaded area. But then I need to subtract off. See, this is 3 right here, right? So I'm going to subtract off this first little bit, right? I need to subtract that part off. Oops. I need to subtract this little area here off, right? So in order to do that, I'm going to take the integral, and then I'm going to do the first part minus the second part, right? I'm going to do the integral of the endpoint. So I'm going to go x to the third over 3, just normal integral, plus c, from 1 to 3. Okay? Now, this notation here means I'm still starting at 1 and ending at 3. Okay, I'm still using this notation here. Now, moving forward, if I then plug in a 3, I get 27 thirds plus c minus, now I'm going to parentheses because everything after this point is going to be subtracted. I'm going to plug in a 1 and I get 1 cubed over 3 plus c, right? Now notice what's going to happen with the c's every single time. Eventually you're going to forget the c's are here, which is part of the reason why we're going to have to remind you many times to add c whenever you have an indefinite integral. In other words, there's no numbers down here. You need to add the c in so that you can have that initial condition. But if the initial condition, if I'm asking how much does it grow, how much area is this yellow part here? I don't care what value it started with. I just want to know, what does it have at 3 minus what does it have at 2? Sorry, what does it have at 1, right? And it doesn't matter where I started, right? If I had 10 gallons of the tub to begin with, it's not going to change how much I grew from 1 to 3. Okay? So if I look at C minus C, that always cancels out, and I end up with 27 minus 1/3. And that's equal to 26/3, and that's how much this area in here is. And again, the idea is you figure out how much you have at 3, you figure out how much you had at 1, you subtract the 2, right? So it's always going to be this final amount. Where's my pen? My pen is down here. So we have my final amount minus my initial amount. So I'm going to plug in for the top. Simplest way to look at it is you're going to plug in the top number minus plug in the bottom number. Okay, so let me do the next one. File, new, don't save. And to do that, I've got to remember what the second problem is. Let me check what the second problem is. Second problem is from 0 to, can't read it. Look at that. That's ridiculously small. 0 to 2, x to the third, it looks like. Okay, so I'm going to go ahead and do that. Hope that's it. You know what? Actually, let me blow that up. I do apologize for not being ready here. View. Make this 1000%. Scroll it down. We'll take a look. See. So this is the worksheet you should have in front of you, hopefully. Oh, this is weird. Do reverse. Okay, so 0 to 2, x to the third. So I was right on that. Okay, so here we go. So I'm going to integrate from 0 to 2, x to the third dx. Okay, so when I go to do that, I'm going to go x to the fourth over 4 plus c, still integrating from 0 to 2. Plug in a 2, I get 2 to the fourth over 4 plus c minus parentheses 0 to the fourth over 4 plus c in parentheses. And that's going to give me 2, 4, 8, 16, 4 minus 0 or 4. All right, I've got a second video I'm going to send out to you as well. Send any email questions you got to me. I will happily try to deal with them. Thank you. Bye. Oh, and that's the assignment.